Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from SGI. We have the Chief Marketing Officer, Franz Aman. Franz, I'd like to welcome you to the show today.
Hey, Rich. Thank you so much for having us. Delighted to be here.
Well, it's great that we could talk before supercomputing. There's a lot going on, and I brought your slides up here. Why don't we go through that first, and we'll follow it with a Q&A.
Sure, my pleasure. So let me just give you some of the highlights, and then we go from there. And if you have any questions, we talk through those. So first off, what are we doing at SC11? We're really focused at announcing and showing our customers and prospects there the next generation in speed and scale. And we have a long history of being the trusted leader in technical computing, everything that needs speed and scale. And we've done tons of work in earth sciences. We've done a lot more recently in life sciences, particularly around genomics. We've done a lot of work around computational fluid dynamics. We've even added some software in our portfolio on that. And we are doing a lot of big data projects as well, particularly with Hadoop. We see a lot of interesting growth in that space. And, there's always so much more. But, traditional high-performance computing's been one of our key focus areas, particularly in those areas. And when you look at our customers, I'm just being reasonably new to SGI, I'm just extremely thrilled with what I'm seeing our customers do. And I'm astounded every day looking at how they solved some of the world's toughest problems, what they do. And, you look at Stephen Hawking using our systems to do big cosmos computing and answer questions around big holes in the Big Bang and black holes and the Big Bang, and how people are working on drug discovery and how they're solving really tough problems around cancer and all that. And you see some of our customers be at the very top end of the scale in terms of compute capacity, and NASA with a 1.5 petaflop system today just signed the contract with us and Intel to up that capacity and go to 10 petaflops and beyond. So, it's exciting. It's an exciting time, and with Intel making a move towards their next generation architecture, we have a huge opportunity here because we're going to be out first and we're going to be aggressive with the new Intel architecture. Platform architecture, and we're going to use that for our cloud systems, kind of loosely coupled cluster systems, all the way to our HPC clusters, and of course, we're leveraging all that capability in our shared memory systems, the big brain computers, as I call them, the SGI UV line as well. Now, one of the highlights, of course, is going to be the introduction of the 5th generation of ICE systems. The SGI ICE HPC clusters are definitely one of the flagship products that we have in the market, and customers have used them for generations and have been extremely happy with just the quality, the performance, how robust they are, but the performance as well. The SGI ICE is the fastest supercomputer on the planet, and we're just, with the new SGI ICE X, announcing a yet faster system. And not only that, but the flexibility you have with the ICE system to configure it and custom size it to the workloads that you have is just phenomenal. Everything's based on standard components, Intel architecture, standard industry fabric. We're talking about InfiniBand, of course, and all these things. And you get all that flexible quality performance, but now at even more performance. And what I found is one of the most interesting examples here is how some of our customers deploy multi-generations of ICE under one umbrella. And we'll get to talk about NASA in just a little bit, and we'll go into more detail about that. There's a long list of firsts and onlys, and we could probably be sitting here for another half day going through all that. But just some of the key things I'd like to point out, we said already SGI ISX is the fastest distributed memory system on the planet, and we have the benchmarks to back that up. But it's also probably the most scalable workhorse for CFD, for computational fluid dynamics, and it's being used by auto manufacturers in the airplane industry to do a lot of the modeling and the simulation, to do away with scale prototyping and a lot of testing. Wind tunnels go the way of bye-bye, and we see more and more customers go from thought to product in just one big step. And the SGI ISX and computational fluid dynamics is just one of the key ingredients to make that happen. And I'm not going to go through all the details of first and onlys as we said, but certainly everyone can check this out in detail at the booth and on the slide here. Yeah, so let's talk about some of the customers who have already signed up for SGI ISX and are looking at the increase in capacity that ISX is going to deliver. NASA, I think, one of the most stunning HPC examples. They're running the largest government cloud on the planet. The system today has about 1.5 petaflops, number 7 on the top 500 list. And what's extremely remarkable is that NASA has gone a path of upgrading over the years and moving from 0 to 1.5 petaflops without ever interrupting their operation. And NASA has credited us publicly, making it possible to save more than 2 million compute hours that would have been lost if they would have done a traditional HPC roll out the old, roll in the new style upgrade. So they've kept adding racks of SGI ICE systems, and as they improved the capacity, over the years they started peeling some of the old rack layers off. But even today, they currently have 4 generations of SGI ICE systems under that same umbrella, under the same roof. And that's possible because of the topology that we're using, the hypercube topology that we're using here. And another customer who's already signed up for SGI ISX is NTNU. And that is going to be, I think, a phenomenal system and deployment by the Norwegian University of Science and Technology. About half of it is going to be used for better weather forecasting in the Nordic seaboard in Europe. So, really exciting applications here. And the workloads that we see, of course, a lot in the earth sciences space, a lot computational fluid dynamics, as we discussed, and just in general, a lot of heavy lifting on big algorithmic problems in Cosmos computing as well. And we've introduced a whole dream team of systems and capabilities for big data. Big data is also a big topic at the SC11 show, and I believe we have everything to meet big data needs, not just in the HPC space, but certainly for commercial customers as well. And just a few days ago, we announced the first green power optimized Hadoop cluster based on our rackable system line. And by the way, we're a reseller of Cloudera Hadoop capability, but we've certainly grown up with Hadoop, and we've seen Hadoop in the very early phases when it was still called Project M45 at Yahoo. We were supplying systems and infrastructure for that. Over the course of the years, we've deployed ever bigger, ever more complex Hadoop clusters. Some of the Hadoop clusters are literally in the 10,000 node plus range. We've sold a couple of thousand node clusters just recently. And Hadoop is probably the fastest growing big data technology on the planet right now. And huge opportunity for companies to get better hold, a better handle on unstructured data, understand the patterns in unstructured data, and make that available to business users. So that's one area. Of course, the SGI UV shared memory system, scale-up system is phenomenal in that space. We see it crunch a lot of bioscience data problems, even around genome assembly, around meshing up medical imaging data with mass spectrometry, microscopy, and genomics data. And we have all kinds of structured data deep query capability. We use the UV for signal processing, very high ingest, fast ingest of tons of data and crunching through that. And, of course, whenever you work on big data problems, you also have to worry about where does it go, where does it live, and how can you get hold of it when you need it. And we have a complete storage line of persistent data, active archiving, multi-tier, hierarchical storage, virtualization, and management. And we can park the data in deep freeze on disks that we spin down, so we don't even use up any power if you don't need that data. We believe that disks right now are certainly one of the best ways, one of the most cost-efficient ways of archiving data and have immediate access when you actually need it. And, the disk crisis with Thailand, of course, is a bit of an issue right now. And I think across the industry, we're seeing some fallout from that. But it doesn't fundamentally change that disks have become so affordable that they are at the same price point as tapes. So let's drill down on Hadoop just a little bit more, because in addition to having big scale-up analysis nodes, there's a beautiful opportunity with Hadoop as a unstructured data middleware platform, if you will, to understand data structures, data relationships. And the problem with unstructured data, of course, is that you don't know what shape and size it has and what structure it has when you see it, so you can't easily fit it into a relational database where everything is neatly organized in rows and columns. So with Hadoop, you can figure out what patterns are in the data, and you can then attack it accordingly. And Hadoop grew up as a software solution to be able to use low-end general-purpose systems, borrowed, stolen from different corners of an enterprise, and you just pull together a bunch of systems, you put the Hadoop software on top of it, and it would commandeer the systems, dish out the problem in small bite-sized chunks, and then bring the solution back together, take care of potential node failures and failovers and all that good stuff. So, very nicely architected software to achieve tackling these big unstructured data problems in a distributed fashion without any assumptions about the system size and what kind of systems and whether they would be up or running the next 5 minutes or not. So very nicely architected solution. Now, once you start using Hadoop for very serious applications, and we're seeing now applications like in high-frequency trading, in around stock trades, where a lot of the data of the transaction is being fed into Hadoop clusters to better understand patterns that may not be discoverable with traditional query-type approaches. So now Hadoop is getting into these really mission-critical and sometimes even time-sensitive kind of use cases and situations. And all of a sudden, you find that the things that Hadoop didn't really worry about in the early days are now becoming critical, because Hadoop is becoming a real platform. It's now becoming a platform of choice for enterprises to deal with high volumes of volatile, unstructured data of all shapes and sizes. So in that kind of situation, you have to take a more structured approach to the platform itself and how you run it, because now you want to deploy it in the data center and you need predictable performance out of the Hadoop cluster. So we see customers now move away from the cobbled together sandbox experiment into deploying hundreds of nodes in a very consistent fashion, where the nodes are sized properly to deal with the problem. And, frankly, what we're great at is to custom engineer a compute solution for specific customer situations and use cases. So we have the ability to deliver these complete Hadoop solutions, software loaded, systems configured properly for the use case, the right mix of memory, compute, and spindles, and get you a Hadoop cluster that gives you the best performance to deal with your problems in a very predictable fashion. And there's no one else on the planet who's providing complete Hadoop clusters, racked, stacked, pre-configured, ships them to you, and you can literally get going right away. One of the biggest challenges for Hadoop clusters today is how to install, configure, bring up those clusters, how to get data in, how to get data out. And in all those cases, we have answers because, one, we, as I said, manufacture, put the whole thing together, and ship rack-level integrated systems. We also have the archiving capabilities to then take the data and archive it out. And we certainly have the ingest and I/O capabilities to bring data into a Hadoop cluster very effectively as well. Plus, we provide the complete system management infrastructure around it that lets you run the Hadoop cluster in an optimized fashion all the way down to power optimized. Power optimized meaning that you can get the most Hadoop performance per watt. And I just sat down with a customer earlier today where we had some of the discussions around, do you need turbo mode all the time? Do you need to run at highest performance all the time? And using highest speed at all times is really expensive. We all know that from driving a car. If you go pedal to the metal all the time, your gas mileage is really going south the wrong way. And it's very much the same with compute. If you run your compute cluster at maximum, you use so much more power, so much more electricity than if you keep it at a more sustained average performance level. And what we announced just a few days ago here was the first green Hadoop solution optimized for power consumption. And it gives you predictable performance, but it also gives you the best possible power consumption. And so many of our customers are either constrained in how much power they can bring into a data center, or they just don't want to foot the big power bills. And we can manage our Hadoop clusters all the way down to the CPU wait state level and make sure that we optimize CPU performance at that level. So definitely big data, big scale. We've deployed single clusters as big as 20,000 cores and 20 petabytes of local storage. So I doubt that you'll be finding anything much bigger than that in the marketplace. Most enterprises that we see deploy Hadoop clusters, they're ranging around 150 nodes-ish. But of course, as Hadoop is becoming more popular and being used more aggressively, we see that creep up towards the hundreds of nodes. So wonderful opportunity for enterprises here to make use of a lot more of their data. When you look at a typical enterprise situation, only 20% of the data in an enterprise is structured and available in relational databases. And 80% of the data that an enterprise has is out there in some unstructured form. You can also gain a lot of insight into what's going on in social media and what are some of the patterns of customer requests, complaints, customer service issues. You can understand patterns that are repeated very frequently. You can understand certain sequencing of patterns, and you can put proactive programs in place, understand patterns and issues very early on, ever before someone would think about writing a report and adding the right queries together to understand that something is systemically wrong. So this is one of the big opportunities here. And just to summarize the value that we're delivering from a customer perspective, we optimize for their requirements around any and all parameters, performance, power, density, and price, because we understand it's tough economy out there, and all of us are optimizing around price as well. We have speed and scale, as you see across our product line, whether it's in the highest end of HPC computing, or whether it's around things like big data in Hadoop or cloud. Speed and scale is what we're best at. That's what we do for a living. So we have a world record benchmark around Hadoop. We have amazing TCO, and we have non-blocking network options available. So if you get into a range where you have a lot of communication between the Hadoop nodes, not only can we support gig Ethernet, nope, we can go to InfiniBand as well. And with the trend that we're seeing where Hadoop is growing up into a real platform for enterprise computing around unstructured data, you see customers moving more into the data center, into a structured approach. And then what you get from us, start up and go. You get running, completely configured systems that just need to be cabled up, powered up, and off you go. So, that's in summary what I wanted to share. So, Rich, back to you. Any questions?
Yeah, sure. Thank you for that, Franz. It seems to me, I've heard a lot about Hadoop with big data, but no one's talked about it in terms of energy and power efficiency before. Do you think this kind of gives you a first mover advantage?
I absolutely think that there is an advantage there, because it actually is good in more than one way, right? Not only does it save you significant amounts of money, if you do the calculation on the money side, a lot of the cost in operating compute systems these days, it comes from the power cost. So this is a big factor right then and there, but it's good for the environment too.
So Franz, NASA aims has kind of put a stake in the ground. They want to get to 10 petaflops, and they've chosen the SGI ICE platform to upgrade Pleiades. What can you tell us about Carlsbad 3.0, the platform that they said they're going to get on to get to 10 petaflops?
Yeah, so what was referred to with the code name Carlsbad 3 really is our SGI ICE X product that we're announcing on Monday at SC11, right? That is one and the same system. So it's our next generation ICE platform, and it's a major step forward in terms of density, in terms of performance, and there's tons of cooling options. There's wonderful abilities to have the systems not just in standard racks, but in closed cells, optimized around closed airflow. So I would encourage everyone to just stop by at the booth, and or if you're not at SC11, go to the web, go to sgi.com, and check out all the detail around the SGI ICE X.
Great, that helps. So, SGI has been shipping the Altix UV systems for about a year now, I think. What are customers telling you about these systems, these big memory, these big brain systems that can run these huge single system image kind of problems?
Yeah, first off, what everyone loves about the UV is that programming and using big memory is just incredibly simple. And if you imagine that you write the little program, or you run a program that you have, and it instantly has access to thousands of cores and up to 16 terabyte of main memory, you don't have to worry about how do I write the program to optimize it for a cluster environment, right? We have customers who literally, they write a program on a PC, and then they move it to the UV, and it just scales and it does big things. So customers love that fact. Customers love the fact that the UV has amazing ingest capability. We can load up to 3 terabytes a second into the UV because we have many parallel spigots that go straight into big memory. Just the fact that you have 16 terabytes of main memory, no one else can do it. So that immediately makes it the tool of choice for many use cases where there is no other solution, particularly around genome assembly and some other things like that. And for scale-up analysis nodes, a beautiful opportunity to do more in-memory analysis at large scale.
So kind of a wrap-up question here, Franz. The Altix Ice Cube, the container-based systems were announced a while back. A number of vendors shipping these containers, but it seems like they're starting to get traction out there in the HPC space. What kind of success is SGI seeing in that area?
We're doing, I think we're doing really well in that space. I would say we're seeing a lot of deployments that we can't talk about. So think of some three-letter agencies and just in general in the government space. But we also see HPC customers who just don't have space. And they're happy to put a modular data center out in the backyard. And that gets them around a lot of the complex permitting and planning issues and so on and so forth. So it's definitely a concept that's here to stay. I'd say modular data centers work. We have the best, most efficient cooling energy management for our IceCube Air. So in terms of PUE, we're leading the pack, and we've seen that customers are running a whole container of gear with just a garden hose and nothing else.
So that's amazing. Well, Franz Aman, CMO of SGI, I want to thank you for coming on the show today.
Hey, thanks for having me, Rich.
Oh, it's been my pleasure. Okay, folks, that's it for the Rich Report. We'll see you this week at SC11.